making AI projects successful. I'm Tonya Hall, and joining me is Dr. Kathryn Hume, Senior Director of Product and Business Development at Borealis AI. Welcome, Kathryn.
Thanks so much for having me.
Absolutely. What is Borealis AI known for?
So we are the machine learning research lab for the Royal Bank of Canada, which is the largest bank in Canada. And as the name suggests, we focus on developing products that are powered by machine learning for the bank.
You just published a white paper titled How to Spot a Machine Learning Opportunity and Make AI Projects Successful. What prompted you to write the paper?
So it was largely, as the title suggests, an opportunity to educate my colleagues, both at the bank and then people more broadly working in industry, on how to make machine learning really impactful in their business. And it has two parts. The first is basically a guide to understanding what machine learning actually is so that people could reconcile an opportunity in their business. And then the second part is more on the product development lifecycle. So how machine learning products differ from standard software applications and some of the tricks of the trade to actually bringing a product to life in the real world.
So tell us, how do you spot a machine learning opportunity? Do you start with the business need and work backward, or do you consider the types of problems that machine learning can solve and maybe hunt for them in enterprise?
Yeah, I actually think it's a mixture between the two. So one of the common failure modes is trying to actually make a dichotomy. You know, do you start with the business problem or do you start with the technical capability? And what we find is that if we were to only go and meet with our business partners and stakeholders and ask them what they want us to work on, because they don't have the knowledge of what's possible in machine learning, the algorithmic capabilities, they might present problems that aren't necessarily like taking advantage of the state of the art. So we find that first off, it's definitely a dialectic between and a conversation between, you know, the business team who knows their domain and then the technical team who knows what's possible using data and algorithms. The second part, what we try to do in the paper is to provide intuitions to people, even if they're not necessarily scientists or not necessarily technical, on the fact that when you have an algorithm, you have inputs and outputs. And those inputs depend upon data, and the outputs are some way in which the data has been processed that then needs to be integrated into a product to do something useful for someone. So there's a large portion in the paper that just basically prompts the reader to think about different types of data: time series data, structured data, image data, text data, speech, voice, whatever that may be. Think about where that exists in their business, and then do a simple exercise, not thinking too much about the algorithms, but just mapping. Here's my input, here's what an output could be, so that they can start to cycle on where there might be an opportunity.
To what degree do machines refine their own algorithms on their own versus human curation or refinement?
Oh, it's a great question. I think it actually depends upon the problem and it depends upon the techniques that the scientist uses. So on the one end of the spectrum, we can almost go all the way, you know, to rules-based systems where the machines aren't refining anything on their own. The humans coming in, they are analyzing a problem, an aspect of that problem that they can define with clear rules, and then they build a program that executes the process the same way every time. You go into sort of the beginning of data science and machine learning, and we'll have a human who will come in, find the features, think about the weights associated with those features, and then sort of handcraft a function that does a decent job mapping the technical problem for a given use case. Then we move almost towards, you know, the deep learning layer where we remove those handcrafted features from the equation and let the algorithm define its own parameters on what might be a good solution, a good program for the problem. And then we can go a step further to the domain of auto ML, where the hyperparameters, right? So the overall structures and architecture of, say, a neural network can be automatically tuned to best fit the problem. And so there's this scale around human involvement in constructing the system, all the way towards a little bit more automation in the system being presented with data and cycling through options to automatically find, you know, the best fit of the algorithm for the equation.
What guidelines and policies do you recommend for building data sets?
Ooh, I think there's this famous adage, garbage in, garbage out. And I can say that I think the answer to this question depends upon the environment that one is working in. If you're a brand new startup and you can start fresh and think about designing a product interface where from the very get-go, you're minimizing the error, duplication, like the mess that can come in with a particular data set so as to have a fresher start to then lead to clean inputs and like better algorithmic outputs. I think there's some of the policies would be savvy about that design interface from the get-go to make it so that there's minimal error from humans in messing everything up. If you're working in an enterprise, you often don't have that luxury. So, working at a place like the Royal Bank of Canada, any bank in North America, you've got systems that date back to the 1950s, 60s, 70s, potentially paper-based forms that were used prior to any automation and computation. And like, this is the stuff you have to work with. It can be a competitive advantage to extract out hundreds of years of information from these paper-based forms, but that requires often some sort of OCR technology, et cetera, to even make the data accessible for computation in the first place. So in the enterprise setting, I almost feel like the policy is, don't look for perfection because you're never going to get it. And you need to have the foundations and setting up a good data warehouse, making sure that you make it faster and easier for scientists to access data, and then try to make it so that things are cleaner in the future. But it's never perfect. so it's best to be creative and use what you have.
Are AI development projects the sole domain of data scientists, or have the tools improved enough that non-PhDs can tackle these problems?
Yeah, so I think it often depends upon the problem. I would say there's never a problem where it's only a scientist's job to solve. In any case, you're going to want to have a collaboration between somebody who is a subject matter expert. Say we're doing something that might be automating maybe a legal or compliance task. There'd be somebody in the business who's been doing this for a pretty long time and will have intuitions and knowledge about how the process works that when paired with a scientist can lead to a better algorithmic result. So on the one hand, it always is a team sport, right? It's never just that we have a bunch of data, pass it to the scientists, and then using the magic of algorithms, they come up with a solution. On the flip side, there are some exciting developments in machine learning today. We're working on a project here at Borealis where a non-technical end user can ask a question that normally would require SQL analysis to answer. So the workflow would be, a business person has a question, passes that to a data analyst who goes into the data tables, runs a query, performs some operation, and then finds a way to present it in a way that's meaningful to the end user. We're trying to automate that entire process. And it's very cool. It's taking advantage of semantic parsing capabilities where we're taking a user's language, parsing it out to make it cognizable by a database, right? Mapping it to the database fields, and then understanding how the grammar can be translated to some sort of syntactical operation. So it's fun, and it'll be really interesting to see how that evolves. Not the realm of AI so much, but of business intelligence in the future.
Dr. Kathryn Hume, Senior Director of Product and Business Development at Borealis AI. Thanks for taking some time to join us and talk about the work that you're doing. If somebody wants to connect with you, Kathryn, how can they do that?
So 2 places. On Twitter, my handle is @HumeKathryn. And then, of course, on LinkedIn, you can find me at Kathryn Hume.
Sounds good. Thanks again, Kathryn. And if you guys want to find more of my interviews, you can do that right here or go to tonyahall.net. Thanks for watching.